I continue, I just want to tell you that on Wednesday and next Sunday, there will be no class. Okay. Wednesday, Thursday, and Sunday there will be no class. Okay. Because of Deepavali, if not mistaken. Okay. So make sure you know. It should be no class. Okay. So we continue our study today with 3 topics. Okay. For today, we focus on 3 topics. Balance delta-delta connection, balance delta-Y connection, and power in balance system. Okay, so let me go to the textbook. Okay, I suggest you use textbook because it is more organized. Okay, if you use textbook, it is more organized. So I will show you how to draw the balance delta-delta connection. So this is something like this. Okay. So the drawing is something like this, but you need to know how to draw everything. Okay. So let me take out the pen first. Okay, when you want to draw delta 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 or something like this. Sometimes they use delta delta, sometimes they use the symbol. Okay. First you have to do the power supply. Okay. Okay, and then do the triangle. And then do the line. Okay, and then do the load. Okay, always use triangle, something like this. Okay, for delta. Okay, this one. Okay, so when labeling, okay, you have to make sure that A always at the top, B always inside the system, something like this, and C is outside the system. Okay, and then the current goes from the source to the load. Okay, this one is IA because this is A, this is B, so IB, and this one is C, IC. Okay, how about the voltage? So for the voltage, VAB, remember you are using the positive sequence. Usually we use positive sequence. Okay, okay, VAB. Okay, this one VBC, and then here VBA. So you need to know how to represent the line. So positive, negative, it is equals to something like this. Okay, means that the head of the arrow is positive, the tail of the arrow is negative. So you need to know all how to draw all of this. Okay, so automatically you will label this. Okay, this is VAB. Okay, let me draw this again. This one VAB. Okay, this one is VBC, and then this one VCA. So you need to transfer all of these into here. Okay, same goes here. Okay, if you go here, you can see that VAB is this way. VAB, and then VCA. This one is VBC. Okay, so make sure you label it properly. Okay, so VAB, it will go from B to A, the arrow. B is negative, CA is positive. Same as here, this one is negative, this one is positive. Okay, how about the current? Okay, current you have to be careful because for load and source, the current is flipped. Okay, so if you want to draw this, okay, maybe I change this. Okay, for current, IAB, okay, means go from A to B. Okay, it's flipped. Okay, this one is I BC, and this one is ICA. Okay, for load, it is from, for example, IAB. The arrow is something like this, A to B. But for the source is this one. Okay, IAB for the source. IAB means that the current goes from B to A. Okay, something like this. Okay, so basically you have to be careful when you draw the current because it is flip. So same as here, this one is AC, CA, sorry, CA, and this one is BC, okay, IBC. So you have to make sure you know how to draw everything. Okay. Now the analysis part. Okay. So for this case, of course, the voltage source you already know. Okay. So VL at source is equals to V line at load. Okay. So V line at source is equals to V line at load. So basically you just VAB is equals to V V phase. Okay, you can use V phase or V line. Okay, and okay, V phase is equals to V line. For delta, the voltage is the same. You can see it here. That's why I suggest you draw this because you can see what is the same, what is not. So VAB is equals to V phase angle 0. Usually we use VAB is angle 0. Okay. VBC is V phase angle negative 120. You have to make sure this is positive sequence. Okay, if you negative sequence, it will be flip. And VCA is equals to VP is angle 120 degree. Okay, and now you already have the voltage. Of course, when it comes to current, you have to calculate the phase because this is delta. I line is not equals to I phase. Okay, you can see it here. Okay, the line current. Okay, this is the line current. Okay, this is the phase current. This one, these two. So basically, it's not the same. For delta, phase current is not same as line current, but the voltage is the same. So first thing you have to do is, of course, you have to calculate the phase current based on the load. Okay. So IAB is equals to VAB divided by Z. Okay, this because this is Z balance load, so all of these are the same. Let me change this. This one is Z, this one is Z, this one is Z. So basically all the load is the same. So VP, okay, VP angle 0 divided by Z, and then IBC is equals to VBC divided by Z is VP angle negative 120 degree, okay, divided by Z, and then I cannot scroll. Okay, and ICA is equals to VCA divided by Z, and then VP angle 120 degree divided by Z. Okay, so basically you already found the phase current. Now after you find the phase current, you have to find the line current. Okay, for line current you have to use two-way. Either you use Kirchhoff current law or the formula. Okay, formula only for balanced load. Balance load means that all of this Z is the same. So either you use Kirchhoff current law or the formula. So because this is the balance load, you can use the formula. But if you want to use the Kirchhoff current law, also can. So I give you example IA. You look at this point A, okay, this one. Okay, you look at that point. So IA equals to input output. So I AB minus I C A. So the trick is you can see here, if you want to find A, the beginning and the end is the same. Okay, same as IB is equals to IB minus IB. So you just use the positive sequence I B C. So I C A B. Okay, something like this. Okay, same as IC is equals to I. Okay, so you use, because you want to find C here, C and minus I C. Okay, the trick is you find the positive sequence is IAB, BBC, CA. So this one is CA. This one is IAB, IBC. So this one is BC. Okay, so that is the trick. But this one usually for unbalanced load, or you want to derive it. Okay, but for your case, this is a balanced load, so I suggest you just use the formula because it is much more easy. Okay, this one. So I use the formula. So I line is equals to I phase multiplied by square root of 3 angle negative 30 degree. Okay, so make sure for delta you use this formula. Okay, for star connection, okay, remember star connection, V line is equals to V phase multiplied by square root 3 angle 30 degree. Okay, so this one is positive, this one is negative, but this one is star. So you don't use this one, you use this one. Okay, this one is for delta. So if you want to use the formula, okay, let me change this. Okay, so you use formula, so IA, so equals to, so for IA you use this one. Okay, you look at the first letter. Okay, so IA is equals to IAB, okay, square root 3, okay, multiplied by square root 3 angle negative 30. Okay, IB is equals to IBC multiplied by square root 3 angle negative 30. IC is equals to IB multiplied by square root 3 angle negative 30. So you already obtained the phase voltage, phase current, line voltage, line current. So all of this already complete. So this is how you calculate everything. Okay, in the delta connection. So anyone have a question before we proceed to the next part? Okay, only 5 of you. Okay, so we take a break about 5 minutes. Okay, you digest this delta connection, and we will continue on 8:25. Okay. Okay.